who here deals with content management systems on a regular basis? Yeah, so that's at least 120% of you. This is a problem that I am looking forward to seeing your solution for as well, because this is something I deal with regularly. I've been quite a fan of Elasticsearch, or Elastic, as you guys are now called. Up now, we basically have two Joshuas who are going to talk all about Elasticsearch and Drupal, and a real-world example of how they used Elasticsearch's really powerful search and analysis functionality to solve a problem in a real-world situation with lots of data. So the two Joshuas, Joshua Lee and, I can't remember your last name.
Rich.
Rich, that's right. I was going to say Lynch for some reason, I don't know why. Okay, Joshua, Rich and Joshua Lee, thank you very much, guys.
Hello guys, we are the Joshes, and we're going to share our experience about Drupal and Elasticsearch in real life. So a little bit about us. I'm a Drupal developer, and I spent 5 years or 6 years working in Australian public sector, and I'm a module maintainer in Drupal community.
So I've been a sysadmin most of my career. I only just started with Elastic maybe about a year ago. It's been a fun ride. I've got a background, before my sysadmin days, I did a PhD. I've been around a little bit, and now with Elastic.
All right, let's start. So I think we're gonna turn this session into kind of like a conversation, like
Scripted conversation.
Okay. So the story started with a year ago. I started to work for the Australian policymakers. Who are they? They are Australian Government, Department of Agriculture, and New Zealand MPI. What do they do? You guys ever come to Australia from overseas, you guys will see some really cute puppies in the airport smelling on your luggage. You'll be wondering whether that's from customs or whichever department. They are from Department of Agriculture, and you guys need to fill a form, saying that I'm bringing into whichever animal-related product or plant product. You have to fill that form to get in. That's also from Department of Agriculture. Because we have kind of like an independent ecosystem, we trying to protect our environment in Australia. That we don't really want foreign species to affect our environment. That's what Department of Agriculture is doing. They are making the policies to stop importing whichever plant or animal product. How they do that? For example, if you know that there's a country who happen to have foot and mouth disease outbreak, and we will know that from Google, from whichever channel, and we will know whichever country imported, related animals. So we're gonna stop importing those animals from all those countries. That's how it works, and they will actually make the policies. The way they do that is currently via a CMS. It's Drupal. Why it's Drupal? Because it's open source, and it was kind of like a ready to use. It has a really big community behind, so it was fine, and it was open source. It's not really a government website. It is serving the global biosecurity community, so anyone can use it, like fish farmers or whatever trading companies with doing the agriculture tradings. And what does this site do? It is using the Google API to search the internet about the biosecurity news and outbreak around the world every day. That's how they do. They used to have a dedicated team manually Googling about the news, and when they got the result from Google, they manually put it into a spreadsheet, but that's bad. So we had a CMS, and Drupal is actually doing the search for us. We have two kinds of queries. One is, we considered untrusted source because that's from Google. We're not sure about whether the source is verified, but we still considering that's available for us. And also we have RSS feed. That can be from different news agents, or it can be from different government.
Josh, a question.
Yeah.
So what kind of what are untrusted sources? Is it just web pages?
Yes.
Is it other email archives, that kind of thing?
Not email archives. So anything from Google search result,
Yep.
we consider that's untrusted. The site allow you to compose the Google queries in different languages. So if you Google about fish disease in different language, it will just return different language. And when we use Google Translate API to translate in the page. Every day, we have a dedicated team to verify the news, whether that's true, whether that's alert, whether that was a promoted. Then we compose the email to all of the registered users to our site. That's been working really well. How that works in the system level, the CI is crawler. So in Drupal, we have a module, using Google API and RSS feed to grab all of the news. Google will only return the URL and a brief description of that result. So we use some third-party web services like GeoNames and Alchemy API to render the metadata, for example, what is the author and which country is this disease from. After we find all of the data, we store that into our Drupal database, which is MySQL. What's happening inside the crawler? We have content type like a search query. So each search query is a Google-like format search queries combined with different keywords. And we have different search source, can be from different RSS feed. And we put them into a Drupal search queue, which is PHP queue, pretty much. And it will run the search and put all of the result URLs into a result queue. And we have the third-party services calling to the result queue to render all of the news. So we know where's that news from, and we can filter something out. This is a interface of that. So you guys can see it. We are displaying where the news happening in the map, and we have a long list of the search result. So pretty much the daily life of the editor, the dedicated team in Department of Agriculture is doing is go in there and search for whatever they want to know about whichever disease. And they can search through the whole history. Currently, we're containing like a 20 years history in our database. And we come with the problems. Well, the way we design the website is like, all right, you have web server, you have Drupal in it, and you create all of the modules and functionalities inside Drupal. Yeah, in theory, that's working, but that's a problem. Every day, we will fire up a cron job. I think it's 4:30, and we have like more than 1,000 Google queries, and we have hundreds of RSS feeds to render. Considering each query will return 10 results, think about how many news we need to write into our database. And, well, our article, our content type is quite complicated, so we have like more than 20 categories associated with all of the articles, which means in Drupal, we have like more than 40 tables to join. That's why when a user performs a search, it actually takes, 5 minutes. And they was like, okay, the site is not working. I have to refresh and research, click the button. It never works. And they will just say, oh, it's not doing it. When I look at it, the database CPU is like 100%. Then I was looking for a solution, but actually inside Drupal, there's nothing that can help me. This is what I found from the new Relic. You see the top query. It's actually selecting, it's a search article from a cache table. That's even a cache table. And the second top one is article places, because the article places got longitude, latitude, country, province, street name, postcode. That's a lot tables to join. So that's taking a lot of time. Top 3, a node, which is a single article in Drupal. Since we have like more than 20 fields in Drupal in each node, then we will actually joining like a lot tables in MySQL. So I was like, okay, that's how Drupal works. That's how it is designed. We can't really do anything other than just doubling your resource in that DB server, but it's not really the final solution for it. So we've been looking for the solution. Maybe it would be great if we can remove all of those search functionality away from Drupal, because it's not really a web server. It's not really a website doing. Websites are really displaying information to you guys. For the internal searching one and the rendering data one, it should be in a separate place. It shouldn't be in the website. And also, considering that we have a lot of tables to join, maybe it's time for NoSQL to jump in. Then this thing came out.
Yeah, so maybe I'll start by asking, like, besides right now and when we introduced the talk, who has never heard of Elasticsearch until now? All right, cool, awesome. So this is our description of Elasticsearch, and it looks like a lot of words here. It is a lot of words, and it's a lot of big words, maybe. A distributed, scalable, highly available, document-oriented, RESTful, full-text search engine with real-time search and analytics capabilities. Whew! Now, that seems like a lot of stuff there, and hopefully in the next couple of slides, we can find out how you can use Elasticsearch, and that might make some of that jargon we see there a little bit more clear. So we'll just have a look at some of the uses of Elasticsearch. Who's used Wikipedia? Cool. So when you type in that search box in Wikipedia and it's doing that autocomplete, that's Elasticsearch powering that search right there. So it's powering that autocomplete functionality and those relevance of the results you're seeing when whatever term you're searching on there. So in this case, we're searching for Elastic, and you can see a couple of autocompletes happening there. That's all Elasticsearch powered. Same thing, who uses GitHub? GitHub's search is also Elasticsearch. So here's another type of search. That's an example of like a full text search. You're just searching for a term, and it's auto-completing for a bunch of terms. It's just finding the most relevant terms and suggesting them to you. So completely unstructured sort of search. Here's a more structured sort of search. This is where you have, I guess, like a bunch of, maybe you go and pre-fill a bunch of terms, like grab some, in this case it's for an auto search website, so you're grabbing things like the model of the cars, the year of their manufacturer, that kind of stuff, and you're like, I guess, having a form-like interface to search. So you're presenting a few options to the user, and the user can like essentially filter their search. So there's a bit of structure there. That's another way you can use Elasticsearch. Here's another example. Anyone seen this? This is the 1 million tweets picture done by Maptimize. I think they did it before they were called Maptimize. So this is a Geo Search. It's actually showing you the last million tweets in real time, and it's showing you where those tweets were based on their geo information. Again, Maptimize, they're using Elasticsearch to power something like that. Here's a sort of like, I guess, a little internal example. So it's not just about like searching for text. You can also do numbers into Elasticsearch. In this particular case, here's some time series data. This is just showing timeline. I actually lied, this data isn't actually in Elasticsearch, but it's showing you how you can essentially put metric data in there and do things like time series analysis here. So in this case, it's got some World Bank data looking at some populations of countries throughout the years, some patents like put out by various countries over time, those kind of statistics. So you're putting in just basically numbers, and you're essentially searching and aggregating on those numbers and presenting them. And then finally, this is a fairly new sort of application of Elasticsearch, which is a graph sort of way of presenting data. So we have a graph API and we have a graph GUI, and this is the graph GUI. In this particular case, this is like basically the top artists of Last.fm users, and we're looking at the relevance, or like what artists are connected to others based on those users. So we're using the power of the Elasticsearch's relevance to like draw connections between these artists based on that user data. So you can see various connections, Nirvana, Metallica, Smashing Pumpkins, some big connections there, but maybe also some like, I guess, less common sort of like connections maybe there, some more unique bands. So some like maybe uncommonly common sort of bands between these various like essentially completely independent people and just with like some kind of music taste they might have in common.
Josh?
Yep.
Question about that. I'm quite interested in that. That's new to me too. I think I can use this graph tool to actually demonstrate the connection between different countries in terms of biosecurity. So, for example, Australia and New Zealand will have quite strong relationship in terms of whichever peasant disease. But we may find out that Australia actually connected to some other country that we didn't really know. And that's really useful to me. Thanks for that.
Yeah, no worries. So yeah, so basically Elasticsearch is like this full text sort of and metric sort of search engine and analytics sort of solution. But we also had a few other terms when we had that definition, RESTful sort of, I guess like API sort of driven sort of thing. And that's basically, it's just a REST API. It's JSON in, JSON out. And this is just some examples of like how you'd interact with Elasticsearch, just some pseudo examples here. You can see that like in the first case here, we're just inserting a document. So we just put, just essentially a HTTP verb, put, into this index, this type of document, and this is its ID, and this is our statement. It's PHP is awesome. Maybe we add another document into that index. Perl sucks. I actually like Perl. We go and fetch a document. In this case, we're just fetching that first document. If we fetch that, that would just return essentially that JSON there. PHP is awesome. Maybe then we want to update that because it is super awesome. And if we would just want to search for the PHP terms, you can see that we're just doing a search on the URL, just like you would do in most websites. Just Q equals PHP would return this first document, but not this Perl one. Because, who's interested in Perl? So we also said it was like easy to scale. It was all built, scale is built in. I guess this is just what I wanted to demonstrate in this slide. So scaling is built into Elasticsearch. It's not some add-on product or anything like that. The author, Shai, he originally built it with the whole idea of that it's going to be this kind of system that you're going to need more than one machine to run it eventually because your data is going to grow as whatever the application of it grows. So this is just sort of a demonstration to explain what that means when we say it's scalable. So initially you'll start your little server, your Elasticsearch server. It's all alone, it's got no data, it's empty. So you might add some documents to it. So in this case, we've added 3 documents here, P0, P1, and P2. To scale it out, and maybe provide a bit of high availability and resiliency, we might add a second node here. And what we can do is we can assign some replicas. So we've actually now got a copy of our data on these 2 nodes. And this is something Elasticsearch can all manage for you. So basically, if this node goes and disappears, maybe it's got a hardware failure, maybe there's a network connectivity issue or something like that, you've still got access to that data on that node, exact copy of it over there. And then, as you get bigger, maybe you want to spread out your data a little bit. Maybe you want to improve search performance or indexing performance or, get a bit more availability and resiliency. So here we're adding a 3rd node, and Elasticsearch has gone and distributed our data throughout this cluster now, these 3 nodes. So now we've got essentially a copy of the data on at least 2 nodes. So for example, if this first node goes down, we'd lose P1 and P2, but we actually have a copy of P1 over here and P2 over here. So it doesn't matter that that node disappears. We've still got access to all of our data. It's been distributed out throughout the cluster. So it's a really nifty feature of Elasticsearch. So just to compare, I guess, and maybe not so much to compare, against some other familiar things. Who's used Solr? I guess that's one which is used as a search sort of interface or search engine for various websites and things like that. So Solr is also based on Apache Lucene. Elasticsearch is based on Apache Lucene. We both use that. We use a JSON-based API. I think they use a sort of like an XML sort of schema. We provide some near real-time search and instant direct document retrieval capabilities. What I mean there is that by near real-time search is that you can index a document and then basically within a second it'll be available for search. It's really hard to do real-time search. It's easy to do real-time retrieval. So if you index a document and you know its ID, you can just grab it again. I mean, it's there. But to search for a bunch of documents, that's a lot harder. Anyone who's telling you they can do real-time search is probably lying. And most of the time, it's probably near real-time. It's designed to scale horizontally. So we don't scale vertically. You don't buy big boxes. You buy lots of smaller boxes, and you distribute it out that way. That's all built into Elasticsearch. And it has these powerful data analytics. We haven't really shown that here, but there's various things like you can do statistical aggregations on your data, various other sort of like analytics and that kind of stuff, you know, see what are the most common terms, that kind of stuff. That's all built into Elasticsearch as well. So there's a lot of power to, I guess, like manipulate and like visualize your data or retrieve information about it other than just its content. Compared to like MySQL and RDM, other like databases like Postgres and stuff like that, there's not really a comparison. They're completely different products. I mean, you know, you're talking SQL versus JSON. If you have a lot of structure and your data doesn't change very much and you don't need search, just use MySQL. It's really good at that. You know, if your data is less structured, maybe the structure changes over time or just changes all the time, and you need to search on your data, you should use a search engine like Elasticsearch. And Elasticsearch has the clustering built in, so it can scale out nice and easily. So there's pros and cons to both. You know, you should use the right tool for the job. That's the ultimate line here. So I'm not trying to disparage these other products. They have their place. So you're best to use the one which is good for your job and what you've got. But sometimes, you know, have a look at Elasticsearch if you think that that's going to be the right tool for you. Back to Josh.
And because of all he said, we choose Elasticsearch. That's a joke. So we chose Elasticsearch as a solution, as part of the solution, because one, we really need a NoSQL database. We can't use MySQL. We have too many tables. Then here comes the candidate, like MongoDB, DynamoDB, and Elasticsearch. But considering that we need to build our custom search function on top of MongoDB and DynamoDB, so we have like why don't we just use Elasticsearch and we just pass whatever search query to Elasticsearch, and they will just give us the result. So that's what we've done. We moved the data manager, the crawler, away from our Drupal website. Drupal website now is just handling with the user management and email sending and some forum. For the core part, we created an app using Symfony to provide all of the endpoint for Drupal or any kind of front-end app to contact with. Inside our Symfony app, we created APIs to search through the internet and dump the data into Elasticsearch database. That I'm quite interested in Elasticsearch that when Josh said we can actually visualize the data. So that's one of the requirements from the department. They were like, okay, we have a lot of data in our database, and you know we have 20 years data, but we have no idea what's happening inside our database. Elasticsearch will be the right tool for us to explore our data. After I implement this new architecture, the performance issue was solved. Well, when I was comparing, I was setting up a Vagrant box, and everything was all like in the same condition. The old architecture was like for search, it would take like 6 minutes, and for a general view of articles, it would take like 3 minutes. But with Elasticsearch and with this new architecture, a normal search through the 20 years history data will be less than 5 seconds. And for a general page load, it will be less than 2 seconds. So that's a lot improved, and that's happening in my Vagrant box. Let's talk about the future. I just said the department was like they want to know what's going on within their database. So they want to know in what year, what disease happened in whichever country that may actually affect the Australian industry. And they also want to know whether in future or near future, this kind of peasant disease will happen in whichever country that may affect Australia. Currently, we don't have that function yet. And I'm wondering how Elasticsearch can help us to achieve this.
Yeah, so I guess one thing which we have, well, we've been talking a lot about Elasticsearch. Elastic itself has a bunch of other things. So Elasticsearch has an open source search engine thing. We also have this open source visualization tool, which is essentially designed for Elasticsearch called Cabana. And Cabana is a nice sort of like easy way to build dashboards which look into your data in Elasticsearch. It's all pointy clicky, you know, you drag and drop, all JavaScript, nice fancy website, nice modern design, that kind of stuff. You can see here I've got a Cabana instance, and you can see a bunch of visualization types there. So things like area charts, data tables, heat maps, tile maps, bar charts, line charts. You can do all that kind of stuff in Cabana through a nice like interface. You don't have to get down into the down and dirty command line or anything like that. You can all like basically visualize your data in a graphical way, which is really nice. So you can end up having nice dashboards looking like this. Just shows off some of the visualizations here. So on the left, this is a dashboard of LA crime data for I think about two years to like 3 years ago or something like that. So you can see things like you can visualize like a geo map of the most like the hot spots of crime. So just don't go in this area. So you can do things like, you know, like nice little pie charts and bar charts, and you can do your bar charts can have like multiple segments to represent different, like I guess, parts of your data. So you can do all that kind of stuff. Here on the right is another example, just a whole bunch of line charts. This is actually, this is on my home server. This is actually pings from my home connection to various like IP addresses, like my ISP and various other things there. So I just wrote a tool called PingBeat, which is just, it's based on another open source product we have called Beats, which is just sort of like very lightweight shippers which ship data into Elasticsearch. Usually it's kind of Unix-like philosophy of doing one thing and doing it really well, but then shipping it into Elasticsearch. So in this case, the PingBeat program I wrote just does ICMP pings and of a whole bunch of hosts and just writes that data into Elasticsearch. Just writes the ping, doesn't do any like averages or anything like that. I can do all that averages and all that kind of stuff through the analytics in Elasticsearch. So I just write the raw data and then I can generate graphs like this. So you can do things like your metrics and then obviously your line charts. This is actually interestingly, this is a 7-day thing. This sort of only started, these lumps every evening at about 7 to 11 p.m. This sort of only manifested around March this year. Does anyone know why that would be? Yes, bloody Netflix and everyone else on my ISP watching Netflix all night. Trying to catch up on whatever they're watching. And it happens all over the place. So I think this is just like really, this is mostly my ISP's servers, and then this is just about the rest of the internet. And you can see that it actually manifests itself, besides these two anomalies here, throughout, like everything sucks when people are watching Netflix, so.
Question. How easy to set up that dashboard?
That's easy. I mean, as I said, it's all drag and drop. So it's just, you know, like if you know what your data looks like or something like that, and you know, these are line charts, and if you understand how these visualizations work, which, you know, if you're a human, you will, you know, it's relatively easy to do that. So, yeah.
If I want to display some nice charts in my website, how can I use the chart from Cabana?
So yeah, it has some functions to embed and export the data, so you can basically embed it as an iframe or something like that. So
that will be dynamic, or that will be static?
Yeah, it's dynamic. So right. Yeah, you know, the only constraint is you've got to have access to that Cabana instance basically to generate the data.
Yeah, cool.
So the other thing which we were talking about before was these analytics and that kind of stuff. So there's a bit of analytics there in Cabana itself, but you can go a bit further. We've got this new feature in Elasticsearch called pipeline aggregations. So basically, you can think of pipeline aggregations. The one I like to, because I'm a bit of a science nerd, is derivative. That's a relatively easy one to understand. You know, if you have like a certain distance and you have and you covered a certain distance in a certain amount of time, if you take the derivative, what are you going to get? Speed. You're going to get your speed. So it's just the rate of change, you know, how much distance did you travel in a certain increment of time. So basically that's what pipeline aggregations can do. You can do derivatives on your data in Elasticsearch. So things like you could, you know, say you're doing network traffic in your, you know, you're storing the raw network traffic, you know, at this point in time there's this much network traffic, at this later point in time you've got that much network traffic. You can actually calculate the rate of change of that network traffic. Maybe then you can start doing things like analyzing trends, like, oh, look, my network traffic just spiked in like, you know, from 6 to 10 p.m. or something like that. Why is that? Start looking into things like that. The other thing you could do is smooth out your noisy data. So you have like a data chart, which is, you know, maybe like one of those ones over there, which is all like really jaggedy and stuff like that. You can sort of smooth it out, maybe so that you can see the micro and macro trends in that data as opposed to just a whole bunch of random spikes. The other thing is to do, I guess, a little bit of prediction, you know, so using something like a Holt Winters model or something like that to like maybe predict a trend. So, you know, when I should sell my shares in Elasticsearch and that kind of thing, you know. So you can do a little bit of prediction in there. So there's these pipeline aggregations are a really powerful sort of way of like, you know, sort of analyzing or smoothing or filtering your data.
All right, I got another question. We know that Elastic provide the plugin in Symfony, how we use it. And I noticed that there are other plugins, for example, in Angular and also in Node. I haven't used that yet. I wanted to play with it. I'm wondering, what if the department in future want to create a web app or a native mobile app? How easily we can actually, for example, use Angular to contact the database straight away? Yeah,
so because this is a PHP conference, we actually have a PHP API you can use, a PHP language client. We actually have language clients for a whole bunch. We've even got a language client for Perl. So yeah, we've got like a whole bunch of language clients like JavaScript. So all these kind of things, you can write it in any language you can access Elasticsearch, which is really handy. The guy who writes this PHP client, Zachary Tong, he's like a, what's that hipster term for someone who knows a lot of programming languages? Polyglot or something like that? Yeah, he's basically one of them. He actually has a beard and everything, and he wears like, you know, what is it, like lumberjack shirts, so he's a real hipster. And he writes in a lot of different languages, so yeah, and he maintains our PHP client. And it's really nice. Most of the language clients make it easy for you to access Elasticsearch. You don't have to worry about like getting into the down and dirty of it, connecting to it. They handle things like, you know, sniffing out the topology of your cluster. So you just point it at a couple of your nodes and it will find the entire list of nodes from the cluster, and it can do sort of round robin failover connections to your cluster. You know, you're talking in your language, you know, the language you understand. You're using the data structures of that language to access Elasticsearch. So it's really nice sort of way of doing it, and we try very hard to like make sure that it's very language orientated, so it's easy for, you know, if you're a PHP core dev for 10 years, you can, you know, it's going to be very familiar. It's not going to use some kind of new paradigm to access that data. So yeah, so a lot of nice features in these language clients, and it's all specific to that language client.
I have one concern. For example, if I want to create an Angular app in my browser, and I enable calls in Elasticsearch server, and is there any like a security risk I need to think about if I want to have the app from my browser connecting to Elasticsearch?
Yeah. So like any database, you know, you obviously want to protect it. We have a solution called Shield, or security we like to call it now, just nice and simple. You know, that can protect your data, your Elasticsearch cluster, of course. But you know, just like any database, you need to protect it. You don't want people being able to like, you know, find out where it is and then start hitting it directly. So obviously, any precautions you take with any other database, you take with Elasticsearch.
Which means that if I don't use Shield, I need to create a custom middleware somewhere, just like we create a Symfony app.
You can create, a proxy or something like that. Various other people, you know, it's open source area. Some people have written plugins for Elasticsearch to essentially add in security, so you can use any of those.
Great.
I think that's it for us. Thank you. Yeah, pretty good. In our latest version, we made a lot of improvements to the geo handling. So Lucene has some like low-level sort of like handling of geo, and we just essentially expose that in a nice, essentially JSON API for you. So yeah, so there you can easily, we have like, as I said, Maptimize's whole business is based on geo stuff, and they use us, and they love it. So you can do all sorts of things like bounding box searches and, you know, Gaussian sort of like, you know, that kind of stuff, like in this, you know, whatever kind of shape you want, all that kind of stuff, filtering on it. Basically anything you can do with like the textual data, you can do with the geo data in Elasticsearch, you know, within reason. I'm not actually sure off the top of my head what the performance is. That would definitely be something I'd recommend you try out. Give it a try. So yeah. So
I think memory is critical. You have to allow enough memory, otherwise the whole thing will slow down.
Yeah. That's a good point.
Yeah.
Any more questions? Cool. We'll just bring the mic to you so we can get it on the recording.
Is the Elasticsearch basically done from an external provider in terms of like you use the APIs to do all the search for you. But can it be used like internally as well, like your own private data?
Yeah, you can use it anywhere. I mean, it's an open source project. You can go and install it. It installs just about anywhere. I think Windows, Linux, Mac, whatever you want. So you can run it yourself. We've got a hosted solution. Yeah, and you can use it in any kind of data. As I said, like I'm actually a support engineer for Elasticsearch, and I deal with customers. Some of them use it for the pure logging solution. Some people like Maptimize, they use it for all this geo data. Other people use it for static data sets. You know, it's all sorts of crazy stuff. Some people use it for document storage and retrieval. It's, you know, like legal documents and things like that, or, you know, long form documents. So it's pretty flexible in terms of what we see. It just blows my mind when people come and say what they're using it for. So, yeah.
There's some legacy systems too in like a Interbase, so there's good drivers for that as well.
What's that?
Like Interbase?
Innobase?
It's pretty old, yeah.
In terms of like how does it compare, or
How it would crawl through the data sets and...
yeah. So there is a bunch of connectors for various things. So there's we actually have a JDBC connector for our Logstash tool. So you can read data out of SQL, like an SQL-based data store, and stick it into Elasticsearch so that you have like fast search on it. So yeah, essentially there could be a connector out there for that kind of thing. So yeah, I've heard of like connectors for various enterprisey software like Trim, that kind of stuff. So yeah, like records management software and that kind of stuff. People like basically index that into Elasticsearch and then search on it. So yeah, there's potential there. So that's a very valid use case. Is like if you have a very large data store of like petabytes or terabytes of data, one thing which Elasticsearch really isn't is a storage engine. It's a search engine. So in some cases, it can be worth leaving that data in its existing storage engine because maybe it has that resiliency and like performance for storage, and just like basically indexing a little bit into Elasticsearch you need to search on at any point in time.
So in Logstash, it has a lot of plugins. So we've been using one of the plugins in Drupal to actually load all of the Drupal logs into Elasticsearch straight away. So if you don't need to write any custom apps or queries to index the data into the database. You just need to use Logstash, install it, just configure it, and that will run. I think how many plugins do you have?
Oh, lots, yeah, hundreds, yeah. So it's called Logstash, but it's essentially a data pipeline filter sort of thing. Does some enrichment and things like that. It's kind of like outlived its name a little.
Hi. The pipelines you were talking about before, would they be equivalent to something like MapReduce in MongoDB?
The
and if so,
pipeline
how would they be written?
Yeah, I guess. We have a connector for Hadoop. You know, Hadoop has its uses like any of those tools I listed. So depends. You'd really have to look at your pipeline and like what you're doing in Hadoop and see if you can do it in Elasticsearch. I think if you're really doing hardcore sort of scientific analysis and things like that, you're probably still going to be using Hadoop. But you can certainly store your data in HDFS and index it to and from Elasticsearch to basically use it to search on. So you can do your hardcore like processing in Hadoop, you know, using pig, whatever, and then just basically index it into Elasticsearch and search on it, you know, maybe if you're presenting it into a GUI or something like that, you know.
What's the indexing speed like the time between when you index something to when it's actually will come up in results?
So it depends once you've got data. By default, It's 1 second. So you index something, and that's just the default refresh interval. So it's 1 second. So you index something, it's available in a second. If you just want to get it, like you index it, you get an ID, and you retrieve it directly. That's instantaneously happens. So and then obviously as you scale more data, trying to keep that 1 second or like essentially a sub-millisecond, I guess, search retrieval sort of thing for all your searches, that's going to be your key thing. And that just basically comes down to hardware and performance tuning. Yeah, I guess we should clarify that, like, for its index, 1 second, but then, if you're searching all the time, like your search performance can be a lot different. So, like if you've got data existing in there, that search performance, that can be milliseconds, sub-milliseconds, that kind of stuff. So only once if you index something and you want to search on it immediately, you're basically going to have to wait a second.
Hi.
Hey.
Can you search on multiple properties of related documents?
Yeah, you can search on anything. You can do terms filters, things like that. This equals this equals that kind of stuff. and or booleans, all that kind of stuff.
Right, and I mean on related documents. So for example, if you search for a book, you can search by author name and the year the book was published and blah, blah, blah on the different documents.
Yep, that's right. Yeah, you can do that kind of searching. So yeah, so as that example of Auto Scout, that's basically that kind of like faceted sort of search where, you know, maybe cars made between 1981 and 1990 of like made by Ford, that kind of thing. Yeah, that's all stuff essentially filtering down your data.
Yeah. I think that's a filter API.
Yep.
In there.
Yep. So yeah, so Elasticsearch has this rich sort of query DSL which you can use to access it. So you can do just those. I just showed some pretty like plain examples there of just searching on a random term, and you'll just get essentially the 10 most relevant results back by default. But you can do all sorts of crazy ass filters. So yeah, with all sorts of scoring and boosting and, you know, whatever, like, you know, if you've got some custom like queries, like, you know, sort of thing that you want to do, you can probably do in Elasticsearch.
Well, good. That's it.
Cool.
Then-